Hello everybody, how y'all doing? Hope everybody is having a great night. Is it night? Yeah. 2 a.m. So it's morning, I guess. Um Today I'll be covering this is probably gonna be the longest video I'll post for this midterm. And the reason being is because right now I'm covering classes inheritance. Uh it's a little bit weird to wrap your head around. It's not hard, but comprehension. You need to have a lot of thinking and comprehension, that's it. Um I'll be covering a lot of different concepts of inheritance. So, inheriting from multiple classes, inheriting from a class from another class, having multiple parents. Um, what else we got? Uh, uh, Polymorphism, I think it's called. I'm not good with names, but I'll cover a lot of concepts that you'll need for this midterm, if not more. Uh, okay, so let's head straight into it. I've drawn this little table that tells us what we're trying to do here. We're gonna have one class that's gonna be a grandparent, and he's gonna have a first name, last name, and age. And he's gonna get first name, get last name, and get age. He's gonna have a constructor to construct these three, and he's gonna have a method that is just drive, which prints out sure I'll drive. All right. Under it, I have a parent, same thing, except this parent has a wife name. Let's just assume this guy's wife is dead. So, wife name and a getter, and he has the same drive that will give us sure I'll drive. And then we have the child of this parent, which is the grandchild of this grandparent. This child has a first name, last name, age, right? He has a new variable, which is mom name, and get mom's name, which is this guy's wife. And we are going to override this method because obviously a child is too young to drive. He's also going to have his own constructor to construct these. And this child has a friend. We only know this friend's first name, and we know he has a toy car name. And obviously as a constructor, I will construct these. So let's start here. The first thing we'll have is my I string, because I have strings, so I'll need it. We of course need our int main, and now we're gonna start with my class grandparent. All right, here you go. Have this, and we said this grandparent has a first name, right? And he has a last name. He as well has an age, and what else do we say he has? And there you go. Okay, and these are gonna be private, right? Since we have getters, so we're gonna set getters here in public. But I like to put my constructor before the getters for some reason. Don't ask me why. So we're gonna put here grandparent, the constructor, which takes its first name. I keep doing this capital letter, it's so annoying. And it's gonna take an int age, and it's gonna construct. So we're gonna say this first name equals first name, and this last name. By this, by the way, I am referring to this last name and not this last name. All right, which I mentioned last video, and we obviously have the age equals age. And this is my simple constructor, nothing too special. And I'm also gonna have my getters. Get first name, and this will return me the first name. Right, and under here I'll copy this, and here I'll have my last name. There you go. Actually, it's last name like that. And we'll also have my int get age, and this will return me my age, or grandpa's age, right? So that is done for this. We also have a drive. So we're gonna go here, and we're gonna get the drive, which is it's just gonna be a void drive, which we said prints out I can drive. Nothing too complicated, you know? Pretty simple so far. This is just a class, has his name, he has a first name, last name, he has an age, and he has all these stuff for constructor. These will get us, since this is private, and we have this function that just says I'll drive. You see right now when we go here and we say grandparent, and then I want to initialize, you know, grandpa, let's say grandpa, and then grandpa takes, so you can either do equals grandparent to call your constructor and pass it what it needs, or there's another syntax where you could just do it like this, and this will automatically call it. And so let's say his first name is Alex, last name is Michael, and we can say his age is 59, or actually my favorite number. There you go. So you see now when I print out his information, which is grandpa dot first name. So let's make this clean, where we'll do first name grandpa dot first get first name. There you go. You can do we'll do /n, and I'll do, you know, last name. If you want, if you feel okay with this, you can speed through this part. I'm just making it for those who have a hard time understanding this, so you can get every single step in the way. I could speed through this and just put it, but then for the people who don't understand it, they're gonna be like, oh, how do you get here? So that's why I'm doing all these little steps. Get H, and that's about it. STD and O. And here we don't need those paces. Ooh. Yeah, all good. So let's test it out. Compile. So we're gonna say I don't have make actually now, so deploy.cpp /main, and you see we got what we need, which is great. Now we need our parent. So what I'm gonna do to make this look cleaner, whoops, I deleted that by accident. There you go. So this is compact, it looks cleaner. Now here, I'll do my class parent. And there you go. And we're gonna say same thing. So you see, instead of this, I'm just gonna copy that and make my life much easier, because it's the same thing. So even for these, for this part, it's the same thing. So I'm just gonna put it here. The only difference is this is a parent. So you see all the underlying is gone. But we also said our parent takes a wife name and a get. So let's give him that. It is std string wife name. Right? And we have a getter, which is std string get wife name. Never mess with the damn wife, bro. You know, wife name. There you go. This will also get us the wife's name. And we also said he has to drive. So let's give him that. I think that got inherited. There you go. Not inherited, but I copied it. And that's that. So you see right now, this is also done. Now I'm going to actually close this out. And what I do have is a class child. Right? And the child has similar to, what does the child have? Same thing, except one difference. So if I copy this class and I just paste in here, get rid of this. So it has first name, last name, age. It doesn't have a wife name, it has mom name. So mom name, right? This is supposed to be child constructor. And I forgot this part here, I believe. So you see in here, it also takes the wife's name. So this is the wife's name. And there you go. And here we'll say this wife name equals wife name. And that's about it. So we can close you, open you up. What do we have here? We don't have wife name. We have mom name, right? Here we have std string mom name, and here we also have to pass the mom name to the variable. And that's about it. Here we have a wife name. It's supposed to be mom. And you see what I'm doing? All of this work. Here it says I can drive. This is supposed to be I can drive. You know, something like this. So you see what I just did? All this, what happened? Okay. You see all this work that I just did? This is a lot of work. It's so repetitive. I could have made so many mistakes, and I did make so many mistakes. And let's see what else we're missing, actually. Let's keep going, and then we'll get to the last part. We also have the child's friend. So let's get the child's friend where he gets too lonely. So here we'll have a class child friend. And the child friend, actually, I'm going to just write it out real quick because it's not a lot of things. We only know his first name, right? And we know what is going on here. Okay, there you go. Semicolon. And we know he has a toy car name, right? And this is going to be private, right? And oops. Okay. And we also have a getter for that. So public. And then we have get first name and get last name. So get first name. And it doesn't take any parameters because it just returns us the first name. And you see here, I could also get my toy car name. So get toy car, and this will return me my toy car. There you go. So this has taken 12 minutes, but you can speed through this again. You should have sped through this if you already know this, so you don't waste your time. But for you to understand your code is better like this. Now back to here. This guy doesn't have a drive function. He just has a constructor. So let's make him a quick constructor. This constructor should be short because he doesn't have a lot of things to construct. So child friend, and what we're gonna construct is he's gonna take a first name and he's gonna take a toy car name, right? Toy car. And let's do this just like we've always been doing. So it's gonna be first name equals first name, and gonna be toy car equals toy car. And there you go for consistency. Oops, semicolon. So you see now all of this, all of what I did here is so repetitive. It's extremely repetitive. So what I can do is something called inheritance. You see right now, this class and this class is almost perfectly identical. So what I can do is I can do public grandparent. Now what this saves me, we'll get to why this is red. What this saves me is this will inherit everything that is either in the protected or in the public of grandparent. So this is public, so this will all be inherited here. So if I delete this, what do we have? Get first and get last name. We already have that here inherited. Don't need that no more. Right? Get wife name, that's not here. We need that, we'll keep it. Get age, don't need that. Delete it. I don't know why it doesn't delete it, like when I do that. But whatever. Right? And the drive is also the same. Don't need that. Delete it. So now, what I've inherited is everything in the public. Now, another thing is, here I have a last name and I have a first name. Same thing here. So why don't I put these in protected instead? So if I do protected, or actually, yeah, even the age. So I can make this whole thing protected. Now, what does protected mean? Protected means if you're outside these brackets, you can't access them, just like private. But our parent or our child class, so parent is the child of grandparent because it's inheriting, and so our child class can access these. But if you're outside of the child and the grandparent, you can't access them. Make sense? So now what I do is I can get rid of this because I've just inherited it. So now this is basically copied here, and these are copied down here. Now with the constructor says there's no default constructor exists for class grandparent. What does this mean? When I'm constructing my parent, I'm obviously setting my first name to this first name, but there's no first name here. What I'm doing is I'm setting it to this first name. And the compiler treats this first name as the parent's first name, or it's actually a grandparent's first name. It's a little bit confusing, but imagine copying this here. All right, so imagine copying this here by inheriting it, except there's like a flag that says this is from grandparent. This is where I got it from, right? So what it means is, how will I access this if I never construct grandparent? I can't, because this is an object, it's not an instance. When I create an instance of this, how will I get access to the last name? Right? It doesn't make sense, because like when I create an instance of this is just an object. I can't access this. This is just some skeleton. So I have to construct this as well. And the way to do that is you put these two dots, same as up here, and you call the grandparents constructor. And what you do is you pass it what you're taking. So I'm taking first name. I have two of these. So let's get rid of that. I'm taking first name, last name, and age. So I'm going to pass it what I'm taking, which is first name, aka this first name. I'm going to pass it to it. And I am taking also last name. And I'm taking age. Now, since I'm doing this, and this is already done up here, I don't need to do this anymore. And now I am constructing it normally. And what I've added to it is even this. So watch. Right now, when I go, let's close these. Close that. When I go here, and let's say I copy this, and I make a parent out of it. So this is going to be parent. Right? And this is going to be, let's say dad, since he has a wife's name. And this guy's name is going to be Johnny. And his last name is Michael, same as his dad, let's say. And he's like 36 years old. Right? Now, when I'm creating this, you see there's a problem. The problem is my parent also takes a wife now. So I'm going to give him a wife name. What's her name? Selena. Selena, you're Alex's wife. Deal with it. So now I am constructing this. Oops, I gave it to the wrong place. Sorry, Selena, I married you to a 69-year-old by accident. But let's give Johnny Selena, and Selena, you know, because it's a good wife. So there you go. See, now this works just fine. It's just this I have to do dad, dad, and here I could also do, you know, /n, wife name, and I could do dad dot get wife name. There you go. You see, now what I'm doing is when I construct this, the code goes up here. I have first name, last name, into age. This is not in my constructor, and I'm inheriting it from here. So we'll go to my grandparent, construct it, and then inherit it. Then we'll go here, wife name, okay, wife name, which is right here. So now my grandparent doesn't have access to my wife's name, but my parent has access to these variables and has access to these because I inherit from it. So it's a one-way street. You know, your grandparent doesn't have access to your wife, but you have access to your dad's age and name and last name and all that. Make sense? And you see right now, even though the get drive is not here, I could access it. So I could say, you know, dad.get drive, or sorry, drive. And you see this will do like will run the function. What's the issue here? And L. No operand match. Oh, this, it doesn't return anything. Oops, I forgot. This just prints it. There you go. So you see it right here. When I run this, let's compile. Main plus main. Oops, can't type today. You see, now I have the grandparent, Alex Michael 69. I have the dad, which is Johnny Michael, age 36. His wife's name is Selena, and he can drive. See, I called it here, and it called even though it wasn't in here, because I'm inheriting from the grandparent. Now there's another thing. For my child, well, not my child, thank God, but for this child, what I have is these are the same as the grandparent. I can inherit these from the grandparent. Let's remove those. I'll remove those from here. It will be the same concept, right? Let's see. These three are also from there. So first name, let's get rid of those. Get age is also inherited from the grandparent. This drive is not inherited, and we'll talk more about that in a minute. So right now, let's inherit the granddad here. The public grandparent. And you see, I inherited it. The constructor gotta do the same thing. Grandparent, and here I'll do first name, last name, and age, because that's when I'm inheriting. And this is the difference, right? Now, when I create this, here we'll do child, and then yeah, just kid, I guess. Actually, why am I doing this? I copied it for a reason. So we'll make this kid, and this guy's name is Johnny Jr. Last name is same as his dad and his grandparent. Selena is not his, okay, so his age is, let's say, 10. Selena is not his wife in this case, it's his mom. So you see that? It still takes the same parameter, but it means differently. And we will have the same thing here, kid. Let's copy that. There you go, there you go. And this is going to be mom's name. And here it's not going to be get wife name, it's going to be get, you see it underlines. Because I'm not inheriting from parent, I'm inheriting from grand. And you see parent has the get wife, but the grand doesn't have a get wife. Therefore, this is going to be my get mom name. See, the underline goes because I have it right here. And another thing is the drive. So you're going to think, when I did inheritance from grandparent, I have this function get drive which says I can drive. But what I'm doing here is I'm naming the same function and I'm saying I can't drive, I'm too young. So when I call it as a kid, which one runs, the inherited function or the function I defined? This is called, I believe, overriding. Yeah, I think it's overriding. So this function overrides this upper function. And the way it works is when the compiler runs and it sees a function with this name, the first thing it checks is the class it was ran to. You see, kid runs child class. So the first thing it checks is inside the child class. Do I have this? If it doesn't, it will go to the parent class and be like, is it here? If it's not here either, I'll tell you, oh, there's an issue. Where are you getting this from? But if it is there, it will use that instead. Okay, so it's like a table of hierarchy. And you see now, let's run it. Did we make any mistakes? You see, we have Johnny Jr., Michael, 10 years old. His mom name is Selena, and I can't drive. I'm too young. Now, another thing with inheritance is you can inherit from 2 different classes. And you see right now, what I want to inherit from is child friend. And what I do want to inherit is the toy car, right? Now, when you inherit something, you see right now when I'm inheriting, like we spoke earlier here as a child, when I'm inheriting grandparent, I am not inheriting is private. So he doesn't have any private. But if these were private, then I'll have an issue. And the issue, let's see, where is it? Where's my kid? Where's my kid? There's my kid. When I initialize it, I cannot run these because these are private. Let's see if we can compile this. Oh, it's actually compiled. I'm so surprised. Did I save? It's saved. And they are private. String mom. I'm constructing it. That's actually pretty odd. I'm surprised that worked. This usually is not supposed to work. Because the reason this technically shouldn't work, because you cannot inherit private. So if I take this and I take this and I put it here, the get age should not work. So you see it all stayed away because it says the function declared in line 10 is inaccessible because my child doesn't inherit private members. So that's why I was surprised that it actually did work. It's not supposed to. But I am not too sure what's going on with that. I'll have to look a little more into it. It might be something to do with the constructor. That might be why. But anyways, so the point is that right now, when I want to inherit the toy car from this, let's say my child also has a toy car. Instead of me writing, std string toy car and all that, what I could do is I can simply just keep this private and make this protected. So I can inherit it. And now I can inherit the toy car without inheriting the first name, because I'm already inheriting the first name from the granddad. Where is it? From the granddad, right? So now what I can do is this child can now inherit 2 classes. So the second class I'm going to inherit is my child friend. You do the same thing, syntax, which is public, and that will inherit it. Now the thing is, you see here, same thing with the constructor. So you'll have to say what you're inheriting, which is child friend, and I am inheriting the toy car. Toy car. But here we gotta do toy car, and right here, well, toy car will be sent here. That's why we're inheriting it. What is the issue here? Oh, I see. So right here in my child, I'm taking 2 arguments for this constructor. So what I can do is make a second constructor that only takes 1 argument. So I can just construct that and just inherit it. This here, what I'm going to say is toy car. And I can do this toy car equals toy car. See, now this works because now it's constructing with this instead of this. So it doesn't need both parameters, it only needs 1. And so what I'm inheriting from the child friend is this, which is a toy car, and I'm inheriting the get toy car as well as get first name. If I don't want to inherit my get first name here, I can just put this in private, and then I won't be able to inherit it. All right. So now, as you can see, get first name, what does it say, is ambiguous. You see, the reason saying it's ambiguous is because I have a get first name that I'm inheriting from the grandparent, which is the same thing as my get first name here. Even though this is private, I guess the code is not processing that, which is a little bit weird. So what you could do is just remove this all together. You don't need it. There you go. But now I can inherit just fine. Here I'm having an issue, which says the child constructor matches argument list. Because my child, we've added a new one, which is toy car. So let's add the toy car name. Camaro. There you go. So you see now I'm going to be constructing this child from the inheritance of grandparent plus inheriting another parent. So this child has two parent classes and it's inheriting two different things. All right. Now the second concept of inheritance is multiple. So it's like hierarchy, let's say. So watch this. If I do instead of my child now, let's get rid of this. Get rid of this. And that's about it. Now let's say I want to inherit parent. So if I change this to parent instead, this will inherit both. So here I'll have parent, and the parent constructor takes first name. We're gonna inherit first name from the parent. We're gonna inherit last name from the parent, and we're gonna inherit age from the parent, and as well as wife name. We're gonna pass it. Yeah, in our case, the wife name is gonna be this variable, which is actually mom name. There you go. So I don't need this. But the thing is, I remove these, then this would be technically a wife name is what I'm inheriting. But I don't want to inherit that. So I'm going to keep this as name, and this is already in the private, so I don't inherit it to begin with. Right? But the parent's mom name is the same as the wife name. That's what it passes as. That's fine. And here, what is it saying? Not virtual base. All right. So we can get rid of this. Okay. So the way this is working right now, you'll find out that even if I go here to the parent and I remove one of its functions, let's say I write here like a function that returns go sleep, right? I don't know. It's just a random function. It's just prints go sleep. Well, now if I take this function actually, and I'm gonna put it in the grandpa instead. One thing you're gonna find out is that even though I'm inheriting the parent, this also inherits the parent plus the parent of the parent. So it will also inherit this. So you see this function is inside my grandparent. If I go to my child and I run it, so is my child, yeah, my child's not taking this anymore. So if I go to my child and I do id dot, you see, I have access to this function. You see, when I compile here, I do g++, main, turning non-void. What do I have here? Whoops, I think I know. It's right here. This is a void because not returning anything. There you go. You see, now when I do this, he says go sleep, which is this. But I'm not inheriting the grandparent. How do I have access to this function? The way it works is when you inherit the parent, this also inherits the parent of the parent you're inheriting. So I will not only inherit this, but also what comes from the grandparent, which is this. Make sense? Now, the other thing is that, so you see, so one thing is we said you can inherit from two different classes. Second thing is if you inherit from one class, which is also inheriting from another class, you'll inherit both classes. All right. So if grandparent was also inheriting from a third class, then the child will inherit the parent, the grandparent, and that third class. All right. The other concept is something called polymorphism or some shit like that. What polymorphism means is that you can return the same type as an inherited class. What does this mean exactly? So you know how when we're doing int a, we're telling it what we're getting, right? And this has to be the same type. So usually, watch this. Right now, I'm only going to inherit the grandparent. I'm going to go backwards to when I inherited the grandparent. There you go. Is there anything wrong with my code? Johnny. What's wrong with Johnny? Takes a mom name, which is fine. It doesn't take this. There you go. So now we're back where the child is inheriting from the grandparent. Now we're going to apply polymorphism. All right. Now let's say I have a child type. Okay, so I have a class child. And this child, I'm going to make it a pointer. And this is going to be just a pointer. It's a child pointer that points to the address of my kid. Right? This is going to be capital K. So now I have a child type pointer that points to this kid instance. Right? And the reason I'm not getting an issue with it is because the pointer is a type child, which is pointing to an also type child, which is fine. But the thing is, if I make this grandparent, it can also, you see, I don't get an error. Why is that? The grandparent, the inherited class, can point to the child. Because the way it works is when you create an inheritance, so let's say here, the child is inheriting from the grandpa. The way it works is it goes like this. We have the grandparent expands out. I can only expand this instead of the whole thing. Expands out, and then you'll get your child instance in there, in here, right? So you can point from the grandparent to the child, but you can't point from the child to the grandparent. So here, I'll show you guys proof. We have our grandparent here. I'm gonna make my child pointer. And this is gonna point to the address of grandpa. You see what it says? A value type grandparent star cannot be used to initialize an entity of child. And that's what it means. So you see right now, also, I'm not inheriting from parent. So you see, my child is not inheriting from parent. So what I'm going to do is I'm going to try to make a pointer of parent. So I see parent pointer equals, I'll say pointer 1, different name. And see, this still doesn't work. But let's say I inherit from parent instead. Right? And so this will change to parent. And I believe this will also need a mom name. There you go. That's initialized just fine. Now, what I can do, you see now this is not highlighted, but also the grandparent can point now. The way it works is that this, so let's get rid of this. The grandparent is basically right now, the grandparent is the parent of your class parent. So let's make it the parent. Take this parent, and it's going to be inside here. Because grandparent is the parent of our class. Then the child is inheriting from the parent. So what I'm going to do is the child will inherit from the parent. And so right now, let me just fix this up. You see right now, this grandparent can point to the parent and it can point to the child. And also the parent can point to the child, but the child can't point to the parent, nor can it point to the grandparent. Make sense? So that's polymorphism as well, is where you're not returning the same type you're pointing to, but since it's an inherited, you can. This was a 40-minute lecture, but this should, I hope, explains it very well. If you guys don't really understand it, I can make a second video, or if you want a second video specific to one type of inheritance, then I can cover that in more detail. Thank you for watching. If you reached the end, eat the donut. Thank you.